Yeah, good evening, everybody. Once again, let's wait for 2 more minutes. Meanwhile, I would request the technical trainers to start sharing your screen. You, sir, or Rohida, sir, you may start sharing your screen.
Uh, yes, ma'am.
Let's
Just a
wait for
minute.
2 more minutes and then we are good to begin the session.
Okay.
Okay, Shivam, you're asking for NOC. There is nothing called NOC. Okay. There is something called offer letter for the AICTE students. Okay. That you can take it from your LMS itself. For the GTU students, there is nothing called offer letter. Okay. And there is nothing called NOC or letter of appreciation, nothing. There'll be one certificate that is called your internship completion certificate that will be provided after your internship. Okay, so 15th July is the project submission deadline which we gave you, and you need to wait more than 1 week because we need to validate your projects as well. And apart from that, you have your attendance target to achieve, and you have to complete all the courses on your LMS under advanced section. So these many criterias are there to get the final internship certificate. Right, no offer letters for GTU students, only the internship completion certificate will be given to you. And if you are a GTU student, then definitely you can show your LMS or the courses which you completed from the LMS as the proof to your college if they are demanding means. No offer letter for GTU students. So I guess we have 258 students as of now, but we're expecting all the students to attend the sessions. Some of you are just filling the attendance sheet without attending the sessions, but to make this internship a fruitful one, please attend the sessions and then fill your attendance sheets. I'll start the recording. Yes, project templates will be shared to you students, right? But before that, the trainers, they need to explain you about what you have to do as a project. For that, you need some inputs, right? So in the sessions, in the upcoming sessions, trainers will give you more inputs about your project works. Then they'll share the template in the same Telegram group. From there, you can start working on your project and then you can submit it directly on your LMS. Okay. So I guess I can hand over the session to the technical trainer. Over to you, sir. Thank you.
Okay. Thank you, ma'am. Good evening, everyone. Let me know if I'm audible or not. You can leave a comment in the chat box. Is my skin visible? Am I loud and clear? All right. Perfect. 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 So let's get started. So in last session, we started with machine learning, right? And we also have some hands-on. And the problem that we have solved, it was a type of supervised learning problem. And as we know, in supervised learning, we have two different types of supervised learning, that is regression and classification. Yes, linear regression, exactly, Axel. So the algorithm that we have used, it was linear regression, and we solved one regression problem. Today we will be talking about classification, and we'll try to solve some classification problem, and we'll try to understand what exactly classification is. So let's get started from here. Yes, yeah, logistic regression. Yeah, you're right, telling right path. Not only logistic regression, we'll try to use more than that. All right. So here, so first of all, what exactly classification is? Before moving ahead with the PPT, let me take you to the sketch pad and we'll try to understand what exactly classification is. If we talk about classification, which means we are going to classify something, right? Classifying something means what? Let's suppose we are having one data set. In data set, as you know, what we have independent feature that we are going to consider as X, and we have dependent feature, we also call it as target, right? When target is going to have discrete values. Discrete values means what? Let's suppose we are having a data set. A data set is about cancer patients. Okay, I'm talking about cancer patients. Based on the X, that is details of the customer, no, not customer, patients. If Y is saying whether the person is having cancer or not. Let's suppose we are having some details. Based on the details, it is saying yes. Yes means what? The person is having cancer. If it is no, the person is normal. So here it could be 1 and it could be 0. So what type of data we are having over here? A type of discrete data. So that is classification. Now talking more about classification, the example that we are looking at, it is a type of binary classification. So we can divide classification in two categories. The first one is going to be binary classification, and second one is going to be, yes, exactly, multi-class classification. Multi-class classification. So in binary classification, whenever we are going to train a model, in the target feature, what we are going to have? Only two things, two classes. We are going to have two classes. With the name binary itself, we can understand what we have: 0 and 1 to predict. 0 means what? Like it could be no, and 1 could be yes. The person is going to get loan or not. The patient, that the data that we are having, based on the patient data, the person is having cancer or not. Or if you are having one data set, let's suppose you are having email, and over here you are having what type of email you have, spam or not spam. So based on the email, it is spam or not spam. Again, 1 or 0, yes or no. That is binary classification. When it comes to multi-class classification, we will be having more than two classes to predict. We will be having more than two classes to predict. More than two means what? It could be 0, 1 or 2, right? Now let's suppose you are building a project where you are going to put data of three different classes. Let's suppose you are having three different fruits in your bucket. And based on the data, based on the, let's say you are having the shape, color or texture, whatever you are having, based on that you are classifying which fruit it is. Like if it is apple, you're going to have apple over here. You can have mango, you can have pineapple, right? Just a second, let me adjust the chat window. Just a second. Yeah, we can have pineapple. Now what we are having over here, we are having three classes. Now these three classes could be considered as 0, 1 and 2. So there are plenty of problems when it comes to multi-class classification. We will be starting with binary classification first. We'll try to understand what are the different problems that we can solve. Now when it comes to algorithm, we are also going to talk about algorithms as well. So when it comes to binary classification, so which algorithm we can start with if your data is linearly separable? If your data is linearly separable, you can simply go with logistic regression. Now let's suppose if you are having binary classification, yes, you can go with logistic regression. There will be multiple algorithms also that you can use. But when it comes to multi-class classification, we should start with KNN. That is K nearest neighbor. There will be a few more. You can also use decision tree. Decision tree can be used in both of the cases. A decision tree is the algorithm that you can use in classification as well as in regression. Similarly, you are going to have few more algorithm that comes under bagging and boosting. We can use a random forest. Random forest. Random forest is going to be nothing but collection of decision tree. Yes, exactly. We can have. Sir, can we use SVM here to differentiate them? Yes, you can use SVM over here. You can use SVM. You can also use naive Bayes. Okay, naive Bayes algorithm. Naive Bayes algorithm, it is totally based on Bayes theorem. Can you use multi-class ones for binary? Yes, if I'm going to talk about KNN, I can use it for binary classification. We can use decision tree for binary classification. We can use random forest for binary classification. Now, the thing is that I'm talking about only this one, logistic regression. Logistic regression is best suited for binary only. If you are having binary classification, then you can go with logistic regression. I'm not saying it is not going to give a good result on multi-class classification. It can give, but as compared to KNN, decision tree and all, logistic regression is not going to perform that much well. All right. I hope this part is clear. Let's come back to our PPT. So how we are actually trying to understand this particular classification model. The work principle is going to be same as we have seen in regression. First of all, we are going to have training data. The training data we will be giving to the model. And from this training data, we can have feature extraction. We can extract the features we want. With the training data, we will be having the labels. Labels, that's nothing but the column Y or the target feature that we are having. The model is going to get that particular data. Model will train itself. Then we will be getting the train model. Then we are going to evaluate the model. If the model is working well, we'll go with the next step, that is going to be that we are going to call is deployment. If our model is trained and everything is working well, we will be having that fully functional model. If we are going to give new data point to the model will be able to predict what is going to be the particular level, right? So working principle of both of the supervised learning algorithms, like whether you are using regression or you are using classification, is going to be same. Only the difference is the target feature. In regression, the target feature that we had, were having continuous data, right? The values were continuous. We were trying to predict what is the price of a car, price of a house, count of something, right? But here we are trying to classify something based on the given data. We are talking about classes, different categories. I hope it is clear till now. Can I get some thumbs up? Can you get some thumbs up in the chat box? Okay, yes is also fine. You can type yes, you can give me thumbs up. All right, perfect, perfect, perfect. Let's move ahead. All right, now starting with logistic regression, right? So we will be trying to understand how actually logistic regression works. So logistic regression is going to be the first algorithm that we are going to use to see how basically classification problem is going to be solved. How does logistic regression works? Basically, if you talk about logistic regression, here it is just going to draw a regression line, or you can say a decision boundary between two classes. It is going to draw a decision boundary between two classes. How actually it works? Let's try to understand. Can you show the previous slide? Okay, we will come back to the previous slide, no problem. Okay. Now, talking about our first algorithm, that is logistic regression. Now, first of all, we will try to understand why we are not going to use linear regression for this type of problem. If I'm going to talk about uh, linear regression, so what linear regression algorithm was trying to do, we were having some data points, right? And linear regression model, this algorithm, its goal was to draw a best fit line that is going to touch most of the data point. But here, if you are going to talk about logistic regression, here the thing is going to be different. Now here we are talking about classes. Let's suppose we are having some class over here. This class we are going to consider the yellow data points. We are going to consider, let's say, they belongs to class 1. Then we are going to have some red data points. Let's suppose this data point belong to class 0. Now here the goal of logistic regression algorithm is going to be to draw a regression line that is going to separate these two different classes on the graph. By separating this particular two different classes, what we try to achieve a decision boundary. Now, whenever, sir, linear regression is supervised or unsupervised? It's supervised. Whenever you are going to have Lohita, right? Yeah. Whenever you're going to have column Y, you have something to predict. Wherever you are going to have target feature, based on X, you are going to predict Y. That means you are into supervised learning problem. Supervised learning problem. In supervised, we have regression and classification. Regression we have discussed in the last session. Today we are talking about classification. I hope it is clear, Lohita. All right, so let's come back to logistic regression. Now here, logistic regression is trying to create a decision boundary. We also call it a regression line. That's why it's got its name regression over here. By the help of this decision boundary, let's suppose the model got trained on the data. It is able to decide, it is able to create a decision boundary. Now, if a new data point is going to come in the picture, a new data point is what, let's say this star or this star. Now, based on this particular line, if any data point is coming above this line, is going to be considered as class 1. Any data point coming below this line, it is going to be considered as data point of class 0. This is how logistic regression is going to work. But the thing is that what is the maths involved over here? It's very simple. The math is very simple. You might have learned this thing in school. There is a function is getting used behind the scene. We call it sigmoid function. Sigmoid function. Now, why we are using sigmoid function? Let's try to understand. Let's suppose you are having a graph and the lines, the data points that you are having is here and here, right? If you are going to use linear regression, so it is going to create a regression line, but that is not going to touch most of the data point. Here we are not going to able to decide the decision boundary and all. So this is not going to work for classification. Here in sigmoid, the equation that we are going to use, the equation is going to be 1 by 1 plus exponential of inverse x. Have you seen this equation in your school time? Yes, recording you will get Anmol. Can we also use ReLU activation? A ReLU we can use in neural network. Yeah, sigmoid is one of the activation function over there. Okay, so I am getting yes. So few of you have seen this particular formula in your school time, right? This sigmoid formula. Let's suppose you don't know what exactly this formula is. Let's make it very simple. What exactly this formula is going to do? We are passing x over here, right? X is getting used over here in this equation. Whatever the value of x you're going to pass in sigmoid, after getting passed, it is going to convert between a value in the range of 0 to 1. In 0 to 1. And if when we are going to use sigmoid over here, so here we are going to get a perfect decision boundary that is going to take care of all the data points. Let's suppose we are having the graph over here and we are having some dots over here, here and here. So the line that you're going to see with the help of regression line is going to look like this. That is going to touch most of the data point over here. And here it is also going to have a threshold. Threshold over here, let's say 0.5. By default, it is 0.5, but we can adjust it. We can increase or decrease it according to the problem. What does this threshold means? What does this threshold means? As I told you, sigmoid is going to return the value between these two numbers, 0 to 1. That means here you're going to have 0 and 1. 0.5 is going to be the threshold. If any data point is coming above this region, it is going to be classified as 1, or it is coming below this region, it is going to be classified as 0. This is how logistic regression is going to take its decision based on the value of the sigmoid, how to separate two data points, right? Clear till here, guys? Is it clear till here? The same thing has been explained over here. And yeah, as I told you, logistic regression is used when you are going to have multi-class classification problem. And we use this symbol to denote sigmoid, right? You have used sigmoid or sigma a lot of time, right? In your mathematical equation. I hope it is clear to all. Moving ahead, we are having one algorithm called KNN. Yes, in physics also. In physics, we have used it a lot. I remember my 11th and 12th physics, right? Okay, let's come to KNN. KNN stands for K nearest neighbor. Now, it is very straightforward method to classify two data points, two different data points. But how actually it is going to work? Now, talking about the name only, what is saying? Nearest, neighbors. It is talking about neighbors. How actually it is going to work? Let's try to see. Let's try to understand KNN first. So we will be talking about KNN. Okay, once again, is logistic regression clear to all? Is it clear to all? All right, perfect. So KNN, in other words, we call them K nearest neighbors, the full form. K nearest neighbors. What does nearest neighbors means? And what is the value of K? K is going to be a constant value. Okay, that we are going to decide. By default, it is 5. By default, it is 5. But we can adjust it. We can make it 3. We can make it 2. We can make it any number. Okay. Now, how actually it is going to work? Let's suppose we are having a graph over here, right? And we are having some classes. Here I'm having some classes over here. I'm having one class over here. And I am having one class, let's say, over here. I'm just taking example of 3 different classes. Now, let's suppose a new data point joins over here. Model got trained over here and a new data point joins over here. How model is going to classify this data point? Let's suppose we are having the class, this is 0, this is 1, and this is 2. 3 different class we have. Now, based on the value of K, Now let's suppose the value of k we are taking is 3 right now. 3. What it is going to try to do, it is going to check which data point is my nearest neighbor. Which data point is my nearest neighbor, right? No, we are not talking about cluster, Uday. Don't get misled. We are not talking about cluster. So in cluster, we will be talking about clustering. Right now, we are talking about classification. Don't get confused. I know this type of confusion will come. I have just taken 3 different classes. Now, if my nearest data, k value of k is 3, I have to check which are my 3 nearest neighbor. Let's suppose this data point and this two data point, let me make it 2 data point over here. One data point is here, one data point is here, and there is one red data point. I found these 3 data points as my nearest neighbor. Now, out of 3, I am having 2 yellow data point, right? And I'm having 1 red data point. What is the majority over here? Majority goes with yellow, right? Then this data point, this new data point is going to be classified as data point of class 1. Yellow, exactly, it belongs to yellow. If I am having a new data point over here, again, I'm going to search for my 3 nearest neighbor. So in this case, only I'm getting 3 nearest neighbor from class 2. It will be decided at class 2. If I'm having a new data point over here, then again, I am going to check which are my nearest three nearest neighbor. So red data point is over here, two red data point, 1 blue data point for this point. That means it is going to be class 0. Now, how it is calculating all the distances. How it is calculating all the distances. What is the maths we are using behind? Okay, one Noor is asking, explain KNN again. Noor is asking, explain KNN again. So, in KNN, here we try to predict the data point based on the nearest neighbor. Okay, if the number of nearest neighbor of a particular class is high than other class, then it is going to be considered as distance data point of that particular class. So in this case, what I am having this new data point. So this is what my new data point. New data point. Now here, what we are having, we are going to find the distance. What are the 3 nearest neighbors? Right, 3 nearest neighbors. So in this case, 2 nearest neighbor was from yellow class and 1 nearest neighbor was from red class. If I'm going to put nearest neighbor as 5, then I have to consider 5 nearest neighbor, 5 data points that is near to this data point, new data point. And the distance matrix that we are going to use, there are multiple distance metrics, but by default, it is going to be Euclidean distance. Euclidean distance. I'm talking about the by default distance metric. There are few more. We have Manhattan distance. Yeah, I'm getting the things in the chat box. Sir, if we increase the value of k, classification will more precise. So Uday, the thing is that we have to check the value of k. We have to check the value of k after some iteration. We are not going to consider only 3 is going to be fine, or 5 is going to be fine. Sometime what you will see increasing the number of neighbors is going to, like decrease the accuracy. We have to train the model in a iteration. Iteration means what? Let's suppose I'm going to take range function. I hope you know. I'm going to take range from 1 to 11. That means the value 1 to 10. I will be training the value of k. Like whenever I'm going to create a model of KNN, there is going to be n neighbors, one parameter n neighbors, and here we have to choose number of neighbors. Let's say if I'm going to choose, if I'm going to use a for loop, I will be putting a I over here. I'm going to train the model again and again on a sample of the data, and then I'm going to check what the best accuracy I'm getting at a certain value of I or the value of k. Okay, talking about Euclidean distance, where we are using Euclidean distance and like how it is getting used. In school, you have learned this thing, right? In school only, you have learned this thing. Euclidean distance is going to be nothing when you have to find out the distance between. Just a second. Yeah. Sorry, like I was having some the problem over here. Okay, it's fine now. Let's suppose we are having 2 points, point A and point B. Point A and point B. As we know, on a graph, you are going to have X and Y axis. So the coordinates is going to be, let's say X1 and Y1. And here it is going to be X2 and Y2. And if you talk about the formula is going to be, you can take x2 minus x1 का whole square plus y2 minus y1 का whole square, right? And we are going to take under root of it. So this is the formula of Euclidean distance. This is what you have used in school. And I told you guys, whatever the maths you are going to use in machine learning, it is coming from our school or high school mathematics, not from out of the syllabus, right? And whatever the maths I have discussed, it's you already know it before, right? I hope KNN is clear to everyone. Is it clear, guys? All right, perfect. Let's come over here. So KNN we can use for binary classification as well as for multi-class classification. So here you can see like it is already mentioned over here. If a new data point is coming, so it is going to measure which like how many nearest data points are there. The majority vote will win. Then is going to be considered as the data point of that particular class. All right, for loop, how to optimize? We should train the model till the range. When you are going to train the model till range 10, that is going to be more than enough. Real life use, we are going to implement it in machine learning, right? The project that we are going to see today, we will try to implement logistic regression. We will try to implement KNN. We will try to implement other algorithms as well. Okay. Is KNN clear, guys? How to implement in Python? Yes, we are going to see today how we are going to implement it. Like we have implemented linear regression in the last session. We are going to implement logistic and KNN also. Perfect. Let's move ahead. Now we have decision tree. Now one of the like very what we can do, like a algorithm that is getting used a lot in industry, decision tree. We are not going to use decision tree direct, but I will be showing you. Okay, what will be the probability of KNN's accuracy? Probability. We can't talk about probability right now until and unless we are going to train the model. What type of probability you want to ask, Abhinav? We are not talking about probability. KNN is not based on probability. If something is based on probability, it is one algorithm called naive Bayes. It is totally based on Bayes theorem. Okay, this is in data structure also. That means you're paying attention in the class. Okay, accuracy. Yes, accuracy is going to be there. Uh, whatever the uh, whatever the classification algorithm you are going to use, you are going to see the accuracy score. Okay. So over here, what we are having a data set. Let's suppose we are having a data set. How the decision is going to be made? Let's say, okay, let's suppose we are having one data set. Okay, we are talking about decision decision tree. Let's suppose we have a data set. In this data set, what we are going to have, let's say we are going to have three different features. Okay, three different features, three independent features. The first one is going to be salary. Second one, let's say it is going to be job location. Third one, let's say uh, what you want. Let's say they are going to provide coffee or not. A simple thing I'm taking. They are going to provide coffee or not. And the last column is going to be why, where you are going to say, like it is target. You are going to say, I'm going to accept the offer or reject the offer. So we are going to see based on the salary, job location, and they are giving you coffee or not. What we are going to do, we are going to accept the offer or reject the offer. How we actually make our decision. So there is a decision process whenever you're going to take any decision. So sometimes you have multiple things to keep in your mind. That's what decision tree is going to do. Now decision tree is going to take one of the feature. Okay, there is again some calculation over here, some mathematics behind it. We are not going to talk about it for now. I want to just keep it as simple as possible for you. Now let's suppose we are having we have to take one decision. Based on this decision, we are going to accept or reject the offer. What I want, my salary, when I'm going to join any company, my salary is going to be greater than or equal to 50K per month or not. Okay, 50K per month or not. Based on this, I'm going to take decision. What is going to be the decision that you're going to take? Now, it could be yes. Now, if it is yes, you are going to accept the offer. If it is no, you are going to check for some other things, right? Where is the job location? Where is the job location? Or the job location is, let me write down the job location. Job location. The job location that you want is under 40-kilometer radius or not. Under 40-kilometer radius or not. You don't want to travel a lot, right? You are checking one more thing over here. If it is not, if the thing is not up to the mark, you are also going to see the job location. If the job location is in your hometown or under this particular range, then you can join the job. Again, what you're going to do, you're going to make some decisions. Decision could be what? Yes or no. Now, if it is yes, you are going to accept the offer. If it is no, you are going to again check for some other thing. I'm just just for explaining, I'm just putting this is not actual thing. Are they going to provide you coffee or not? Okay. Let me write it down. Are you going to get coffee or not? Coffee, yes or no. They are providing coffee or not. Now, let's suppose if they are providing you coffee, you are going to say yes and you are going to accept the offer. And if it is no, Here you are going to say, yes, I reject the offer. I don't want this job. Now, what exactly decision tree is? Decision tree is nothing but a upside down tree, right? Upside down tree. Where a tree starts from? A tree starts from root, right? Just a second, let me fix it. Yeah, a tree starts from root, so we are going to call it as root node. This is going to be the root node. And what happened after root? When you go up, you are going to get branches, right? You are going to get branches. Now wherever you are taking decision, like here and here, like here you are taking decisions, here also you are taking multiple decision, we can call these nodes as branch node. Branch node, right? Yes, in data structure you might have gone through this thing, binary tree. Yeah, it looks like same, right? These are going to be branch node. From root we'll go to the branch, and whenever you're going to end the tree, like whenever you're not going to have any split, this particular, this one, this one, also these two, these two, these two, all these things we are going to call it as leaf node. Leaf, like whenever you are going to see leaf is the last part of the tree where the tree is ending. So here the final decision, whenever you are going to take the final decision, that is going to be considered as leaf node. And if you talk about a real-time tree, yes, in real-time tree we have what? We have root, then we have branches. Above the branches you will get more branches, or at the end you are going to find leaf. Sir, can you send GitHub repository link again to the last lecture? Okay, I will be sharing all the GitHub repository link today. Okay, I will be sharing all the GitHub repository link in the Telegram group. Is tomorrow's MS session? Tomorrow is a MS session, but in MS session we are just going to clear doubts regarding the platform and all. If you have any doubt over here, you can just ask me. How to submit project? Okay, we will be guiding you, Fatima, for that. How you are going to submit projects. If I'm going to share the link over here, this Zoom chat will not be here. So I will be sharing the GitHub links in the group. All right. Let's talk about one more thing. Now, whenever you are going to talk about a tree, we used to discuss like what is the height of the tree, right? Here to here, what is the height? Now here we are not going to call it height, we call this as depth of the tree. Depth. How depth this particular tree is going. This is decision tree for you guys. I hope it is clear. Real world example, I will be showing you implementing decision tree. Okay, I will be showing you decision tree. Today in our today's session, in the hands-on session, we are going to implement all these things. Is it clear to all? Will the recording will be shared the YouTube channel also? If we are live, the recording you will get on YouTube also. But ma'am will be sharing the particular thing, the link of the class, the recording link in the group. Okay, don't need to worry about that. All right, so I hope it is clear. So decision tree is nothing but a supervised learning algorithm. The thing that I have explained you, it was in the term of classification, but decision tree can be used for regression as well. Okay. So the goal is going to be very simple, to predict a target variable based on input features. सर आपने डिसीजन ट्री उल्टा समझा दिया, ये उल्टा नहीं है। अब यहाँ देख लो, इस डायग्राम में भी तो सही सेम है। इट्स नॉट उल्टा, इट्स सीधा सीधा। Okay, let's move ahead. Then what we are going to have, random forest. So guys, random forest comes under ensemble technique. Now what does forest means? Can anyone tell me what does forest means? What do you understand from forest? Forest is nothing but collection of trees. Now here in random forest is exactly collection of trees, group of trees, exactly the right answers I'm getting. So what we are going to get over here in random forest. In random forest, we can use n number of decision trees. It is a type of, it's a type of bagging algorithm. What does bagging algorithm? I will be explaining you. Just what we can do here in random forest, we can have decision tree parallelly. Like all the decision trees are going to work parallelly based on the result. We are going to see, like we are going to finalize what is going to be the class. Let me explain all these things, in this particular yeah, wherever I used to explain the things, scribbled ink. Okay, random forest is a kind of ensemble ensemble technique. What does ensemble means? Grouping the things together, right? Keeping the things together. In ensemble, we have two different things in ensemble. The first thing is nothing but bagging. Then we have boosting. Bagging and boosting. Let's try to understand all these things. Yes, they comes under ensemble method. In under bagging, what we are going to have, our algorithm called random forest. Random forest. And the base of random forest is going to be decision tree, the base algorithm. Decision tree, you can't change decision tree over here. But let's suppose you want to use something other, you can use bagging algorithm. There is bagging classifier you can use if you're working with classification problem, or you can use bagging regressor. Bagging regressor. When it comes to boosting, in boosting the algorithm, what exactly bagging and boosting is, I will be explaining you all the things. Just have some patience, okay? In boosting, we have a lot of algorithm in boosting. Few of the algorithm, what we are going to do, we are going to have ADA boost, and one of my favorite algorithm. Also, it is getting used in industry a lot. We call it XGBoost. Yes, XGB. XGB is getting a lot, it is getting used a lot in the industry. These two things, random forest and XGBoost. Okay. The thing is that when to use what? One question will come in your interview, when to use bagging and when to use boosting. Now, when we are going to, have a machine learning, when you're going to train the model, what will happen sometimes? Let's suppose your the train accuracy you have got 80%. But when you're going to test the model, your accuracy got dropped. Let's say 60%. Now, this type of problem, we call it as overfitting. Overfitting is the situation when your model is working well on trained data, but when it is getting test data point, a new data point, its accuracy is getting dropped. It is not predicting the things true. Then we have one more problem called underfitting. Underfitting. So underfitting is the problem where your train accuracy, I'm not talking about test accuracy. Even on train accuracy, your model is having 50% or low accuracy. Like your model is not performing well. Your model is not able to understand the train data. That is underfitting problem, right? So when to use what? Whenever you are going to face overfitting problem, you can go with, whenever you are facing overfitting problem, you can go with bagging technique. Whenever you are facing underfitting problem, you can go with boosting technique. But one of the best thing about boosting is you are going to use bagging when you are facing underfitting problem. You are going to use boosting for underfitting problem as well as when you are facing overfitting problem. You can use both of the things, like for boosting algorithm, you can use in both cases. How they are differ, that's what we are going to discuss, how they are differ. How actually this algorithms works differently. We are going to understand all the things. Let's start from bagging. Okay, bagging. How basically bagging works. Now bagging is going to work differently on regression and on classification. Okay, it is going to work little bit different on regression and classification. Now what we are going to have, let's suppose we are training 3 model at a time. So we are having 3 model or 3 decision tree I'm taking, but we can have more. That means we are having 3 models. In regression, what we are going to have, we will be having a continuous value to predict. Let's suppose you are having model 1, model 2 and model 3. All these models are making its prediction. In regression, let's suppose you're working on a house price data. Model 1 has predicted 3.5 million, the price of the house. Model 2 has predicted 3.9. Model 3 has predicted 3.7. What actually random forest is going to do, or any bagging algorithm is going to do, it is going to take the average of all these three. It is going to take the average of all these three, and it is going to give you the final output. That is going to be the output of random forest, let's say, is going to be the average of all these three, 3.7 million. Okay, this is how it is going to work on regression problem. It is going to take average of all the models. If you are using 100 models at a time, 100 decision tree at a time, so it is going to take the average of the output of all the models. What it is going to do in classification? Okay, again, in classification, yes, I got the answer in the chat box from Pawan. Very good, Pawan. Again, if I'm going to consider, we are having 3 model, M1, M2 and M3. Okay, let me scroll up a bit. In classification, what we predict classes, right? Let's suppose model 1 has predicted 0, model 2 has predicted 1, model 3 has predicted 0. So we are having a binary classification 0 or 1, but 2 models out of 3, 2 models are predicting what? The answer is 0. So here RF, let's say RF, it is going to return the majority vote, right? It is going to take the votes from all the models, the majority vote is 0. If I am having, let's say model 1 is predicting 1, 2 is predicting 1, but model 3 is predicting 0, what is the majority vote? Majority vote goes to 1. So we are going to get 1. This is how random forest is going to work, or any bagging algorithm is going to work. Is it clear? Can I get some thumbs up over here from your side? Hard voting and soft voting. Yeah, I'm getting good comments over here. All right, perfect. Let's talk about boosting now. Now, whether it is bagging or whether it is, whether it is regression or classification, in boosting, we are going to see similar type of work for both. What actually we are going to have? Let's see. Boosting. I am considering the algorithm that we are using is going to be XGBoost. Okay. We are not talking about maths behind it, guys, but just try to understand what we are having. Nothing but we are having what? Decision tree. We are having decision tree, n number of decision tree. I am having n number of decision tree. I can have 100, I can have 200. It totally depends. Okay, one question from Parth. Sir, if we have any disease related data, can we use this bagging? Yes, exactly. You can use for sure. What happen if we have 4 model? Okay, very, very good question over here. Okay, one of the finest question asked by Seeker over here. I am showing you with the help of 3 models, right? I am showing you with the help of 3 models. But what if we are going to use 4 model? 2 models predicting 1 and 2 models predicting 0. So that's why here, I'm not saying always you will be getting this type of confusion. Let's suppose you have used 4 model. Okay, let's suppose you have used 4 model and 2 model is giving you 0, 0 and 2 model is giving you 1. So here we are giving some confusion to the model, right? Our model will get confused. That's why majority time what we will be using it in like I'm not saying you can't use even number, you can use even number, but these are the very rare case. These are the very rare case. Even if it is coming like in classification, you got 0, you got 1. Now this time model is going to have some weightage. Now the thing is that, let's suppose I'm talking about this 2 model and this 2 model. This 2 model is going to give this result based on some accuracy, right? Let's suppose again this 2 model, the first model has given 80% accuracy and the second model has given let's say 70% accuracy. On average it is going to be 75% accuracy. That means 2 models are giving the result with the 75% of the accuracy. Here if you see, let's say I'm just considering with some random data. Let's say first model is giving you 70% accuracy and the second model is giving you over here let's say 90% accuracy. What is going to be the average? Average is going to be nothing but 80. So which is higher? 75% is higher or 80% is higher? So here this weightage is also going to get considered if you are having even number when you are going to train the model. What is the weightage? If the weightage of these 2 models are going to be high, then we are going to consider this result, that is 0. If the weightage of these 2 models are going to be high, we are going to consider this one. When you are going to use regression, then average is going to get considered. But here we have some, confusion in classification. I'm glad you have asked this, Seeker. This is very important thing. This can also this can be also asked in interview. Okay. ये तो न्यूरल नेटवर्क में होता है. न्यूरल नेटवर्क हम लोग पढ़ेंगे. Anamaya. I hope I am pronouncing your name correctly. Okay. Let's talk about boosting now, guys. We had a lot of discussion on bagging now. Let me just erase this thing. Just a second. I see on Kaggle how some models can give 100% accuracy. Now, 100% accuracy is possible on dummy data sets only, Vijay. Okay. you can get 100% accuracy, but if you're getting 100% accuracy, you have to check with the new data point. That time, what we can have overfitting problem. If you're getting 100% accuracy, that means you could get some overfitting problem. You have to check with some test data. In test data, your model is giving right accuracy or not. Test data means what? Completely new data point. 99.6, it's fine, it's good, but again, I'm talking about that accuracy that you're getting on trend data is different. The data that already models know. If you're getting 99% accuracy on the test data, that means your model is working perfectly, like it's working fine. You don't need to do anything. You can see it on Kaggle, guys, those who are looking for data set. Okay, we will be talking about projects, guys. Let's try to complete this thing. Okay, we have to also go with the practical part. Now, talking about boosting over here, what actually we are going to have in boosting? Here we will be having the model in a series. Okay, or you can say in a sequence over here. Let's say we are having model 1. Then we will be having model 2. Then we will be having model 3, till model n. Model n. We don't know the exact number till model n. What in boosting will happen? So first of all, your model 1 is going to get trained. It will make some mistakes, right? And that is going to be transferred. That learning is going to get transferred to this model 2. That means model 2 is also going to look into the mistakes done by the model 1, where the model 1 was lagging. It will try to improve that. Again, the model 2 is going to train itself from the beginning, but is also going to understand what was the mistakes done by the model 1. Then the same thing is going to get transferred. The mistakes will get transferred to model 3. And this steps will goes on and on till model n. Sir, all the models are different. No. Every model is decision tree. This is decision tree. This is decision tree. This is decision tree. This is also decision tree. We are using decision tree in a sequence. Okay. Sir, I don't know library of Python and ML, but I'm a statistics student in learning phase of Python. Yes, you would be able to complete this internship, Anis. Guys, believe in yourself. Okay. Believe in yourself. Let me write it over here. Believe in yourself. I have seen a student with a BBA degree. You are doing statistics. A student with BBA degree is working as a AI engineer. Okay, he is in my touch. So, and I have also seen one guy working with a BA degree as a software engineer with 10 LPA package. So whatever the degree you are pursuing, it doesn't matter. What matters the skill. Okay, let's come back to the topic. Now, the thing is that, let me erase this. Otherwise, you will be asking more questions on this, right? Let's come back to the topic. I will keep this thing. Believe in yourself. This is important. Don't have doubt on yourself. You can do it. Okay. Now, the model that we are going to use over here, initially, these models, this model, this model, this model, we are going to call them as weak learners. Weak learners. Now, with the sequence of weak learners, what we are going to get? We are going to get a strong learner. The final model that you are getting over here, we are going to call it as strong learner. Okay. This is how boosting is going to work. Whether you are using on regression problem or classification problem, the working principle will be like this. Model is going to get trained in sequence, right? Because boosting is mostly used when you are facing when you are facing underfitting problem. Sir, is there any full stack implementation of ML project? Yes, you can use Streamlit to deploy your model. Divya Jyoti. Yeah, you can use Streamlit to deploy your model. You can make it full stack. Full stack is nothing but you are having a front end and you have designed the back end. That's it. So does Streamlit need coding? Very less coding. Very less coding to deploy. You have to just mention what the buttons and all you have to use. You can learn it very easily. Guys, is it clear bagging and boosting? Are you able to understand how random forest work? Okay. Are you able to understand this thing, how random forest is working? I hope it is clear till here. Sir, in this project, I use AI tool or not? You can use AI tool. Boosting again. Okay, once more. Sure. So the thing is that in boosting, we will be having n number of models. Let's suppose we are using n number of models. N number could be 100, 200, any number. So the model is going to get trained in a sequence. First of all, model 1 is going to get trained. Model 1 will get trained and model 1 will make some mistakes. That mistakes are going to be, it will try to be getting improved by model 2. Model 2 will try to improve the mistakes done by the model 1. And model 2 will train itself again. Then the same thing, model 2 can also, make some mistakes. That mistakes are also going to get observed by model 3 and model 3 will try to improve it. Similarly, this particular steps will goes on and on till the last model, that is model n. And the base model that you are going to use is going to be decision tree only. Okay, you will be using decision tree. Whether you're using XGBoost, AdaBoost, anything, you will be using decision tree. Decision tree is going to be the base of all bagging and boosting algorithm. डेटा सेट सेम रहेगा सारे मॉडल में. हाँ, डेटा सेट, हाँ, वन मोर थिंग यू हैव आस्क्ड, लाइक इट इज सेम. देखो, डेटा सेट तो सेम रहेगा, बट द थिंग इज दैट लेट्स सपोज this bucket is our data set. Let's suppose model 1 has taken the data set from here, 75% data to train. Model 2 has taken 75% data from here. Model 3 has taken 75% data from here. So each and every model is going to get different set of data, not same set of data for training and testing. Okay, so it is going to, suffer. We are going to suffer. Boosting is equivalent to upgradation based on the previous experiences. Exactly, Noor. Upgradation, or you can say improvement. When we will receive our project, we have to receive the project from your side. We are not going to give project, right? You have to give project. You have to make project. Okay, I hope it is clear till here to all. Now, how we are going to evaluate the model? Okay. In regression problem, we have used mean square error, mean absolute error, root mean squared error, R squared, adjusted R squared, mean absolute percentage error. So these are the metrics. Metrics are nothing but measures. Okay, metrics are nothing but measures. Okay, what is the difference between AdaBoost and XGBoost? So AdaBoost stands for adapting boosting. XGBoost is extreme gradient boosting. It AdaBoost little bit different. It is just going to have little bit different. Some parameters are going to be a bit different. Learning rate is going to be a bit different over here. Okay. When you are going to see the parameters, then only you are going to understand what is the difference over here. So AdaBoost we used to call adaptive boosting. XGBoost we used to call it what we can say extreme gradient boosting. It is the upgraded version of gradient boosting algorithm. Okay, So in regression, these were the metrics that we have used. Metrics are nothing but the measures that we use to find what actually the model, how actually what the model is performing. In classification, we used to talk about accuracy, precision, recall, specificity, negative predicted value, F1 score, correlation coefficient, all these things. But mostly you will be talking about there will be a report that we are going to create that is called classification report. In classification report, you will be getting precision, recall, all the things all together, right? So these are going to be the evaluation metrics for regression and classification, and evaluation metrics or performance metrics, you can say. These metrics basically help us to understand how well our model is performing. That's it. We have trained the model. Like whenever you are going to complete the semester, you have to give the exam, right? Your exam scores basically tells how much you have understood the things. That's what we try to do. After training the model, we used to test the model, and after testing, we are going to see this particular result, the metrics or nothing but the measures. Hands-on, yeah, we are going to the hands-on now. uh, there will be a hands-on over here. I'm going to share this link with you guys. Let me share this link with you. I'm sharing this link with you right now here. uh, this is the project on topic sir GitHub page, sorry, GitHub repository. This repo link I have shared over here. What we are going to do, we are going to work on this problem. That is going to be, we are going to understand the used cars based on the condition, based on the condition are able to like sold or not, right? Let me open this particular what we can say, the Jupyter notebook, then we'll start working on it. Let me open Jupyter notebook. Okay. Hmm. So answering to your question, who has asked, like let me add something to that difference between ADA boost and gradient boost. So if you talk about XGBoost, that uses gradient optimization. So you might have heard about gradient descent. So it uses gradient optimization with regularization for better accuracy and speed. But if when you're going to talk about ADA boost, like basically it is simple, it is simpler, and as compared to XGBoost, it is not that much powerful. Basically, ADA boost weeks. Sir, can fork this repo? Yes, you can fork this repo, no problem. You can fork this repo. Let me open that particular file. So ADA boost basically, what we can say, it boosts the weak models by focusing on misclassified data. But XGBoost is going to be better option when you are going to use. Let me see the name over here. What was the name of this file? Just a second. Not this one. Just a second. Just give me a minute, guys. Name of the file that we have. Used car. Okay. So I was getting a little bit confused. I'm having a lot of files over here. Yeah, this is the notebook. And I'll tell you how you are going to use Jupyter notebook efficiently. Let's suppose you're not using these things, right? Um, what we can say, you are not using Google Colab, or you are using the things on the local machine, that is your personal system. And what you are going to do, like you want to, yes, you can do in Colab wherever you want, but here I will be showing you all the things on local machine, right? Let's suppose you're not having internet connection, how you're going to work. But everyone is having internet connection, you can use anything, it's on you, but here I will be using local machine. Okay, so the problem that we are going to have, basically it's very simple. The purchase, let's suppose we are purchasing something in the auction. Okay, we are purchasing something in the auction. Based on the details, is going to be good buy or bad buy. We have to understand the car is going to be a good buy or a bad buy based on the car details, right? This is going to be our problem statement. So what we are going to have, we are going to have this data set, a very large data set we are going to use today, and where we are going to do all these things. Here I am going to skip one option. You can download the data set directly from Kaggle. But the thing is that when you're going to download it, it may ask you to, uh, what we can do to enter the, um like API key and username. So I don't want to do that. So I will be directly coming to this step, and here I will be changing the path of the file, and I will be showing you how you can do the same. So first of all, I'm going to import all these important libraries. Okay, it is saying open dataset is not here. Dataset link is already there. Come over here. You have to go here. This is the dataset link. You can see in the repo link. This repo link I have shared with you guys, right? Let me share it again in the chat. This is the dataset link. Otherwise, I will be sharing the dataset in the Telegram group. Don't worry about that dataset. Let's focus on the session for now. Let me go back to the file that I have opened. Okay, one error I have got. What the error is, module not found. What to do when you are getting this error? It is saying I'm not having this module. Okay, I don't need to use this module, although I'm already having this dataset locally. I'm going to install this. Okay, I'm going to install this. Let me add one cell over here. I'm going to add one cell. Here I'm going to write simply pip install open datasets. Now, open dataset is a module that will help you to use dataset directly from many other sources. Let's run this and let's wait and watch, and you will see a lot of files it is going to download. For me, it is saying requirement already satisfied. Okay, you need to restart the kernel. Let me restart the kernel then. Okay. Done. Done. For me, it is installed. Guys, I'm going to just skip these 3 lines of code. If you want, you can do the same. Why I'm skipping? Because the data set is already downloaded in my system. Okay. Beginner friendly ISA. Look, what actually we are going to do. Let me go very beginner friendly. Let me come over here. What problem we are facing now? We are having auction data. We are having auction data, right? In this auction data, we are having the car details, right? We are having the car details of the car, or you can say ABCD of the car. Based on the details, we are going to have one column. The column could be anywhere, not only always at the end. We are going to have a column where it is going to say good or bad. good or bad. So what we are going to do, we are going to give this data set to the model, model is going to get this data set, model will get trained, then model will be able to give you the result on, let's say you are having A, B, C, D over here. When you are going to provide new ABCD, that is new features of the car, model will be able to predict this thing, whether it is good or bad, good or bad, a good buy or a bad buy. Yes, it is an example of classification. We are from the starting of the session, we are discussing about classification only, right? We are discussing about classification only. I hope you understood the problem now. All right, so I hope all of you understood what exactly the problem is. And what we are going to do, we are going to install the important libraries. This step I'm skipping for now. For me, the dataset is already downloaded. You can go with this flow. If you don't want to directly download dataset, you just need to put the link of the URL. Open dataset is going to download the data from this URL, and it may also ask you uh, to give the API key and all from the Kaggle. So if it is going to ask you to give the API key, let me tell you from Kaggle how you're going to get it. You have to go to your profile. When you will go to your profile, you have to click on setting. When you're going to click on setting, here you can see you are getting option create API token. You can create API token. You will be getting a API key, and you will be getting what you can say. You will be getting your username you already know. Username is going to be this one. My username is Pius Pankaj 96. Okay, it is not editable. I hope this part is clear. JSON file you get, you will be getting a JSON file whenever API keys are mostly, like not mostly, every time you will see in JSON file only, right? You can simply copy and paste it, right? When you're going to open JSON file, it will get open in Notepad. So you can simply copy the API keys and all. I'm skipping these two steps. What I'm going to do, let's suppose you are already having the data set in your system, like I have. So what you have to do, you have to go to the file location and you can copy the file path. So you can install Cbond, pip install Cbond. If you're getting this error, you can install Cbond, pip install Cbond. Okay, I have to change the path of this file. I have to read the file from here, but I have to change the path of the file. The file path is not here. I have to change the file path. What I'll do, I will go to the file where I'm having this file. I'm having this file somewhere on my desktop. The folder name is sample project. What I'll do, I will right click on this file, and here I'm going to get one option, copy as path. If you're not getting copy as path option, you can simply, right click over here and you can copy the address, and you have to just put the name of the file. For now, I'm getting the copy path option. I will be using copy as path, and I'm talking about local system. If you're using it in the local system, I'm going to simply replace the path. And one more thing, whenever you're going to do the copy as path, and guys, this is for Windows laptop only. For Mac, it could be different. For Linux operating system, it could be different. For Windows, if you're using Windows, the thing is going to be same. Now here, what I have to do, I have to put R before the path. That means I'm going to read the file from the path. The same thing I'm going to do over here. I'm going to do the same thing over here. I'll paste it because I'm having the both of the files in the same folder. Just the names are different, right? Just the names are different. Where is that folder? Just a second. Yeah, here it is. I'm having test CSV. So I'm just going to put R over here. I'm going to change the name to test CSV. Let's run the code and here we go. We got the data set uploaded. Unicode error. Okay, where you are getting Unicode error? Have you downloaded? What is R? R here it represents read. Reading from this path. Reading from this path. We are giving the file path. All right, let's move ahead. Let's see what is in the training data set. So what we have, we are going to train the model with this training set and we'll be testing the model efficiency or accuracy with the test DF. So in train DF, what we have these features, right? We are having these features. What we have, purchase date, auction, a lot of things we are having. Make, it is Mazda, Dodge, Mercury, Ford, like what are the company are there, Jeep. You can explore the data set. Okay. Now, what is going to be our target feature over here? Can anyone tell me what is going to be target feature? Can you find a target feature? The target feature we are not having in the last. Why in VS Code this file is not running? Yes, good or not? This is going to be the target feature. Is bad by? If it is 0, that means no, it is a good buy. If it is 1, that means yeah, it is bad buy. So this particular feature is going to be our target feature. Let's see, you can also make other feature as target feature based on the requirement, but right now the requirement is we have to understand based on the car detail, it is a good buy or bad buy. Let's see the info. We are having 33 features, right? And we are having few features as integer, that is the ID. Target feature is by bad by integer, and we are having something as object, float, all type of data we are having. So what I will try to do, we'll try to check all these things over here. And okay, no, not 33, we are having 34 columns over here. Okay, 0 to 33, we are having 34 columns here in the train data. In the test data, we are not going to have that. Can you see that is bad by, it's bad by is not here, it's missing. So number of columns you have over here is 33. The shape of our data over here that we are having 34 columns, the train data, here we are having a huge data set, around 73,000 rows, 72,983. For the test purpose, we have taken the data of 48,000, around 49,000 you can say. Okay, so what we can see, training set has 34 columns and test set has 33 columns. Okay, let's go through this thing. Let's try to understand how, like, what are the things we are having in good buy and bad buy. How many cars are for good and how many cars are for bad. We are going to plot a bar plot using Seaborn. Let's run this and oh, something is missing or what? Just a second. I think it is taking some time. Let me add one thing over here. PLT dot show. Okay. I got it 2 times. I have to remove this thing. PLT dot show has taken 2 times. Okay, no problem. So let's consider the last one. Let's consider the last one. Ignore the first one. So what we can see in this data, so many data points, more than 60,000 rows that we are having is for no, and around 10,000 rows we are having for yes. It's a bad buy or it is a no, good buy. Yes or no. What insights we can see over here, like simply 64K values stating good buy and 9K value stating bad buy. So our data is imbalanced. We'll see how to make it imbalanced. Imbalance means what? When in the class, the difference between the number of the data points for each class is having a lot of difference. That says it you are having a imbalanced data set. Moving ahead, let's see how we are going to also see the things according to the auction value count, right? Let's run this query. Okay, why it is not showing up? Sir, is our project will look like this? Yes, sir, you have to follow this procedure. Like it is not going to be the same. I'm not saying you are going to make the project them similarly like this. Do we have to create the in IPYNV file? So where you are going to do the project? You are going to do the project here only, right? In notebook. If you want to do in VS Code, you can do in VS Code. Okay, guys, like something is wrong in my system right now. What I'm facing, I'm getting the things double time. Okay, I will fix this later, but let's try to understand this particular thing. From the auction data, what we can see, like there are three types of auctions: Mannheim, Other, and Adesa. So 56% of the auctions has been. This particular chart is like auction place where maximum number of the time in Mayhem, right? Moving ahead, let's plot one more bar plot based on the vehicle age. What are the different age of the vehicle we are having? Let me simply put this thing plt.show. Okay. So what you can see, like vehicle age in auction, what we can see, the vehicle of 9-year age is the highest than 8-year age. So we can see exponential growth in the age and number of the cars. Most of the vehicle that is getting sold in the auction are 9 years old, 8 years old, 7 years old, and very less car is 1 year old or 2 year old. All right. Moving ahead, what we are going to see. Make, based on the make data, make column. How to install Jupyter? I have explained it in the last session. I will explain you again. Okay. Is it mandatory to use data set in our project? The thing is that Adyasa, without data set, how you're going to train the model? If you're going to make any, if you're going to make project on machine learning, first of all, you have to train the model. For training the model, you need data. Okay, so here what we have got a upside down bar plot. So what we can see, like different cards are here. Based on the make means what? The company name over here. Which car we can see is the highest. So the highest car is getting sold is Hummer, then Toyota Scion, Plymouth, and different cars are there. We are having Nissan, Hyundai, Kia, Ford, and all this. The least number of the cars that we have in the auction is from this company, Chevrolet. Okay. What is the name of the project that we are making? You can see the name of the used car classification. So we are working on an auction data. Based on the car details, we have to identify it is going to be a good buy or not. Okay, we are going to train the model based on that data. All right, moving ahead, let's see the distribution of the vehicle age using histogram. Okay, so what you can see, the highest number of the vehicle that we can see in this histogram, that is, you can see good buy or bad buy. The bad buy is in red color. The highest numbers are of 4-year old, right? Then 3-year old. Then what we have, 5-year old, like this. Moving ahead, let's see based on the make how we are going to see the things over here. So the highest what we can see from Dodge and all, based on the make. Then moving ahead, nationality. Okay, we have one thing called nationality. So most of the things of the like car companies are nothing but American, right? They are American. According to the size, what is going to be? So most of the vehicle that are getting sold in that is getting sold in auction are of medium size, right? People are preferring medium size vehicle. Sir, one chart is enough for the project. Guys, one thing I want to add over here. Okay, one thing I want to add over here. All of you have enrolled for an internship, right? After completing this internship, you are going to get certificate, and you are going to add this thing in your resume, right? When you're going to add this thing in your resume, and whenever you're going to sit for an interview, interviewer will ask what you have done in this internship, what type of project you are going to show. The project with one graph, a simple project, right? You should have a good project. That project is going to represent you in the internship. Try to understand this thing. The project, whatever the project you are going to create, it is going to represent you in the interview. All of you are going to show this thing in your resume that you have been the part of this particular internship. Interviewer will ask 100%. They are going to ask what you have done in the internship, what you have learned, what project you have worked on. So you have to come with a good project, best project of yours, right? I hope I made this clear. Okay, let's see a few more things. So we are having different states over here. In Texas, we are having the highest. Then the wheel type, based on the wheel type. So here we are just trying to explore the data, right? So most of the car that has been sold are alloy wheels, then cover, then special. Most of the cars from alloy wheel. And let's see the heat map over here, the relationship between the vehicles. I'm just going to do plt.so. I'm just adding one thing over here. So heat map is going to take some time. Okay, the value error I'm getting. Okay, so what happened? Okay, so the thing is that over here we are having one column that is not float type. Whenever you're going to plot some correlation matrix, you have to use columns that are the data set that is having only numerical columns. So what we'll do, let's say we are going to for making this thing, we are going to create a new df. What is the name of our data set? Train df. So train df, and we are going to use include. Just a second, guys, just a second, let me fix this error. This error was unexpected. Let me fix this error. Okay, one thing I was missing over here. So what we have to do, autofill वाला ऑप्शन कैसे आ रहा है? Okay, very good question. You're asking autofill वाला ऑप्शन कैसे आ रहा है? So autofill वाले ऑप्शन के लिए आपको let me tell you. Hmm, remind me later. Let me complete this. Otherwise, things will left pending. We have to complete this project. I will explain you about the Jupyter notebook. So what I have to do, I have to take only the selected data type. So select D types, and here I have to include only numeric column. So here I have to mention, I want to use what number. Okay, number should be here in a square bracket. I have to mention number. So we will be having a data frame where we are going to have only numbers included. Now, in the place of train df, I'm going to use numdf. That is the data frame that is having numerical features only. Let's see. Here we go. We got it, right? We fixed the error. So this problem I was facing, I don't know why, but sometime it works, sometime it not works. So the problem that I was facing, usually in correlation matrix, the function used to take only numerical columns. For this time, it was not taking. I think I have to update my Jupyter notebook. Okay. So this particular thing shows correlation matrix, how much a particular column is correlated to each other. In correlation matrix, what you are going to see on the right hand side, a scale. So through this scale, what we can understand, the darker it is, the highly correlated it is, the lighter it is, the least correlated it is. So you can see 0.99. What are these columns? 0.99, where we are getting 99. So MMR acquisition auction clean price is 99% correlated with average price. Clean price is related to average price, right? Let's move ahead. Let's see the scatter plot now. Scatter plot we are going to use to see the relationship between two variables. I think we have already seen this thing. Okay. Okay. So what we can see over here, there is a positive relationship, right? There is a positive relationship. The color basically represents over here two different types of classes, right? Two different type of classes we have. Uh, blue dots represents class 0. One dot, yellow dot represents class 1. So what we have over here, you can see the graph is going up. That means the average price, this auction average price is highly correlate with retail average price, right? So obvious thing, positive correlation we can see. Then yeah, let's see this one. Here also we are getting positive relationship. Then retail price versus MMR current, MMR retail average price versus MMR current retail clean price. What is there? Again, we are having positive relationship over here. Fine. Okay. So what we are going to do over here. Okay, one thing I'm not having over here right now, this particular text file. What I am going to do, I'm going to read this text file. Just a second. This text file we are having on this particular uh, on this particular this particular thing we have to download. So I will be downloading it from here. I think it will get downloaded directly. Okay, perfect. It got downloaded directly. What I'm going to do, I'm just going to copy the path. Let's come back to the file. And here I'm going to paste the path of the file. And here I'm going to put R. Let's see, it's working. Here you go. So basically this file is nothing but it is holding the, details about the features. Okay, this file is holding the details about the features. Okay, perfect. So what we are going to see, how many null values we are having in our data set. So the features that is going to have a lot of null values. So you can see these features are having 0 null values. Here we are taking in the percent way. Trim feature is having 3% null values. Few feature is having 4%. And these two features are having 90%, 95% null values. That means 95% of these particular rows are empty in this column. Okay, so what we are going to do, we are going to we are going to work on this. We'll try to fill something in this particular rows, this particular columns. And before moving ahead, we also want to make some changes. So in train DF, there is a column called transmission. We are having manual. We are going to change manual. Just a second. we are going to change the manual to manual. So this replace function you have already seen, right? Now what we are going to do, we are going to drop these features in the both of the column. Few feature we don't need, that is trim, that is holding. So whatever the feature that is holding null values, a lot of null values, we can drop those features. And we also don't need the purchase date. That column also we don't need. So from the both of the data frame, we are going to drop it. It will get dropped. Perfect. Now when you're going to see df.describe, you will see all these numerical features. All right, so we are good to go. Now what we are going to do now, we are going to train the model. We are going to train the model, and before training the model, we need to prepare the data. So what we are doing, we are taking train target. Target means what? Only the data set over here. Sorry, what we can say, the column that is holding the target values. Then we are dropping this thing from the original data set, the column that we don't need. Done. So here what we have, now we are left with 24 features, right? We have dropped this is bad by also. Is bad by is now stored over here in the train targets. Now what we need to do, whenever you are going to train the model, your model needs numerical data only. Your model needs only numerical data. Now the thing is that if I need numerical data, then what to do with these columns? These columns, like we are having transmission, wheel type and all. So these columns need to be encoded. Encoded means what? We are going to change it to numbers. What we're doing is, first of all, like here we are going to filter out the numerical column first of all. Here what we have, last time in select data types we have used include. Here we are excluding the object, and we will be having a list of numerical columns. Then what we are going to have from scikit-learn.impute, we are having one module called simple imputer. And here simple imputer is going to have a strategy of mean. What we are going to do, we are going to transform this particular data first, the numerical features, right? So, okay, not fitted. It is saying not fitted. Just a second. Something is wrong over here. This simple imputer stance is not fit. Call fit with appropriate arguments. Okay. So we have imported it. And imputer.transform. Let's see. It is working over here. We will come back to it. So still we are having some null values. So what we are going to do, we are going to fill the null values over here with the highest value. Okay, so all the null values will get filled up, and we have 0 null values now. Now we are going to use level encoder. Level encoder will help us to let me give you an example. Let's suppose we are having red, white, maroon and silver. So it is going to assign 0, 1, 2, 3 like this. Auto manual 0 or 1 like this. So level encoder is going to make the changes in the column itself. It is going to change the values, and we will be having the list of categorical data over here, and few of the columns need to be one hot encoded. Now basically what is the difference between this particular level encoding and one hot encoding? In level encoding, we try to make the changes in the same column where we are working on ordinal data. Ordinal data means what? Where we can put something in order. But when we are going to not have any ordinal data, ordinal column, we are having only, like data that is having only names. That time we are going to perform one-hot encoding. What will happen in one-hot encoding? Whatever the classes you have, sorry, the categories you have, there will be a separate column for that categories will get created. And in which column that particular category is present, it will have 1 and other categories will have 0. This is how one-hot encoding will work. So we are calling one-hot encoder on the categorical column. Okay, so it is giving some error over here. Okay, it is giving some error. Sparse, false. Okay, let me remove this. Okay, fine. Now it worked. Sir, can't download this dataset. Please give the dataset link. Okay, let me do one thing. Just a second. You want dataset? Let me give you the dataset here itself. Just give me a second. Okay, so dataset is getting uploaded in the chat. Okay, you will get the dataset from me. Let's move ahead. So what we are having over here, okay, has no attribute get feature names. Okay, it is saying it is not having any attribute called get feature names. A new type of error I'm getting. Always let me see what the problem is over here. Get features names out. Okay, something has been changed over here. Yes guys, I'm using कौन सा column remove होगा, कौन सा column remove होगा. Let me tell you, whatever we are dropping here, like I have mentioned the drop feature somewhere here. These are the columns that we are removing. Okay, dataset I have shared in the chat guys. You can download the dataset from there. I think we have run this cell. Now we are going to get the encoded columns added in our dataset. Okay, again one more error. Columns must have same length. Okay, just a second. Column must be same length as key. What error we are getting over here? Let me see this thing. Encoded calls. Okay, everything is fine. Don't know why I'm getting this error. Let me move ahead. So we are not having this thing over here. Okay, no problem. So what we are going to do, we are going to scale the data. We'll see how that thing can be fixed. So we will be using numerical column. Okay, we are going to drop these columns and let's come to the training part. Okay, so here we are using this particular thing over here and we are going to start with logistic regression. Okay, we will be starting with logistic regression. So here we trained the model and let's see what is the score with logistic regression. How we are using logistic regression from scikit-learn.linear model. We have imported logistic regression and matrix that we are going to use is going to be nothing but confusion matrix. The model score is 87 on input data What about validation data? And we are getting similar result on the test data also. Val input means what? Validation data. It is taken from the test data. Let's ask our model to predict something, and we are going to see the result in confusion matrix. Okay, so in confusion matrix, what you are going to have, I will be plotting the confusion matrix. Let's see the accuracy score first of all for the predicted. So this is the confusion matrix. If you want to plot the confusion matrix, what you can do, these are the predictors. Okay, can you upload this data set in Telegram group? I told you that I will be uploading it after the session, but people were asking for the data set that I have said. That's why I have said over here. I can't open Telegram over here, right? My screen is shared. Okay, so for now, what we can conclude, accuracy, we are getting 87% logistic regression. Let's train the model with KNN. Okay, in KNN, here we are using n neighbors 11. That means 11 neighbors will be taken. You can also change the values. We'll ask our model to train. Let's see the score. The score that model is going to give on train data. Let's see. Here it is taking some time. 87%, right? 87.9%. What about on the test data? Okay, so on test data it is dropping a little bit, 87.6%. So we are getting almost similar result with what we can say KNN also. Let's see decision tree. Now we are having decision tree. Name submission DF is not there. Okay, let it be. So I think it is not uploaded. So we will be creating a model for decision tree. Model will get trained on the inputs and the target. We'll see the confusion matrix and let's see the scores. Okay, let's see the score. What is the accuracy score? It is saying 1, that is 100%. It is giving the result. What about validation score? Now you can see, we can see some overfitting over here. On the trained data, we are getting accuracy score of 100%, but on the test data, the model score is dropping. Right? Can we do project completely on Azure service instead of graphs and all? Graphs, guys, you are taking it, little bit different. Let's plot the tree first. I'll come to that. We have seen one thing over here. Let me plot the tree again, guys. plt dot show. Okay. So what I told you, decision tree is going to be a type of upside down tree. So this is what you can see. So vehicle age has been taken as the first feature over here. Based on that, it is trying to decide, and you will see this particular leaf node. Leaf node is nothing but the result. I have run this cell 2 times. That's why I am getting two decision trees. What was the maximum depth over here? 40. It is saying 40. So what we have seen till now, how the different models are performing. So what we can see, KNN is working fine, logistic regression is working fine. With decision tree, we are getting something wrong over here. Now, what is something wrong over here? The accuracy that we are getting is 79% of the validation. So what we have to do, we have to make some changes in the hyperparameter. Max depth means what? How depth the tree is going. Okay, how depth the tree is going. So here, what we can do. Okay, again I missed something over here. Let me run this again. plt dots. Depth means what? How deep your tree is going. So you can see the based on the important features. These are the important features. What you can do, you can train the model again, right? Train the model again, and you can use these features. So we are going to make the changes and we are going to train the model again. And this time we are getting, you know, good accuracy, 87%, not 100%. We are getting good accuracy, right? And like hyperparameter changing means what? We are changing some things over here. We are changing some parameters in the model. Here we have made the changes in max depth, right? Previously the max depth was 40, it was saying. Now we have made it 3. We have changed some parameter. We can also do the same over here while creating a separate data frame for the model, and we will be giving the same data set to the model to work on. Okay, what we have got with the max depth, so we have trained the model on different max depth. So training error and validation error you can see on the different max depth, right? We can also plot it. Let me add plt dot show over here and we'll be running it again. So you can see what we can see over here. Training error is going low, but when the max depth is becoming high, error is going up for validation data. That is not a good thing, right? And now I'm just moving ahead over here. Let's try the same thing with random forest classifier. This is going to be the last one. Okay, and random forest will take some time. By default, 100 decision tree is going to be trained. What we are getting over here for the train accuracy we are getting 99%, but the test got dropped 11%, that is 88%, right? So these are the difference that we are getting over here. The same thing we can do, we can uh, train the model again with different parameters, right? We can train the model again with the different parameters, and we can also see what are the important features. Based on the important features, the model can be trained again. Okay. So here, what we have understood from the above code. So these are the parameters we can use for the model. We will be training the model again, and we are going to check the score. Guys, you can skip this code, that is submission df. Basically, this data set that we are using, it is coming from a competition, a Kaggle competition. So that's why this submission df is coming. So you can skip this particular line of code wherever you are seeing the submission df. Okay, so what we have got, model accuracy after retraining the model, we are getting 100% accuracy on the trained data and 87% on the test data, validation data. So what we can consider over here, like based on the different, we have tried 4 different algorithms, right? Logistic regression, KNN, decision tree, and random forest. So out of all, like we can see some better result with random forest uh, after doing hyperparameter tuning. Okay. Yes, this is hyperparameter tuning. We have changed something over here, right? We have make some changes. All right. Clear till here, guys? What we can do, like we can also perform some future works over here. We can perform better feature engineering. We can also tune the parameter. There are different options like grid search cv you can use to cross validate and train the model again and again with different parameters. You can also perform cross validation with k-fold. So there are a lot of things that can be done over here. So what you can do, you have the data set, you have the file, try to make some changes on your own. Okay, is it clear to all? All right then, guys, that's all for the day. Yeah, so we are going to meet on Tuesday now. On Tuesday we will be working on we will be talking about unsupervised learning. We'll be discussing the algorithms like k-means and all. F1 score कैसे आएगा? F1 score, and now this thing I want you to find, Annamaya. You have to use, have we used classification report? No. So You can use classification report from scikit-learn.metrics classification report. Okay, classification report से आएगा. Sir, how do I know? One question is here. How do I know how much amount of parameter we have to change? That's what I am telling you now. So we will be changing the parameters based on the hyperparameter tuning through cross validation. You can see the last point. We have to cross validate. So what we are going to do, we are going to take some parameters, we'll be giving some multiple values, and based on that, we will be training the model again. So guys, ma'am has already sent the attendance form link. You can fill out the attendance for the day. Yes, you can do all the things completely on Azure service if you have the access of Azure. Yes, so that's all for the day. Thank you, everyone. Thank you for connecting today. Thank you for your time. When is the next class? Our next class is on Tuesday. Tomorrow we are going to connect
On
for
Tuesday.
AMA session.
Yes,
Tomorrow we are going to
tomorrow
connect
we
for
have
AMA session.
AMA session. Yes.
Yeah. Thanks, ma'am, for reminding.
Yes, Piyush. Thank you so much for such a wonderful session. And students, please remember tomorrow we would want all of you to join the AMA session. Okay. So the links I will be forwarding in your Telegram group. So stay tuned, and we would want all of you to attend the AMA session, because no recordings will be provided for AMA sessions. We would want you to be there. Okay. So further things can be discussed in the AMA session. For now, yes. Thank you so much for attending the session. Thank you.
Yeah. Thank you, everyone. Bye.